23. That is the confirmed count. Iranian vessels neutralized in the Persian Gulf during the most recent operational window. Speedboats, fast attack patrol craft. A Ghadir-class submarine that never completed its transit out of Bandar Abbas harbor. 2 carrier strike groups operating within range. Hundreds of Tomahawk missiles pre-positioned across the theater. A naval kill chain the Pentagon spent 3 decades and roughly $40 billion refining. And here is the number that did not make a single headline. 11 days. That is the gap between the first confirmed engagement and the first public announcement. The first strike was logged 11 days before Iran declared maximum fleet readiness. 11 days before the IRGC announced its fast boat swarms were deploying into the strait. 11 days before the standoff, in any public accounting of the timeline, had begun. The United States Navy had already won a confrontation that Iran did not yet know it had entered. Every channel on this platform will show you the weapons, the carrier deck sortie rates, the Tomahawk counts, the tonnage. Wrong level of analysis. The right question is simpler and harder. How does a military force close a kill chain against an adversary before that adversary has deployed its force, and do it without that adversary knowing the kill chain exists? The answer is an Ohio-class submarine. 1 boat. And what it did during 38 days of absolute silence is what this video is about. Subscribe to Navy Powerline. Because what we are about to show you is not a story about firepower. It is a story about time and who controls it. We have spent the past 3 videos walking through the geometry of Hormuz, the 21 nautical mile choke point. Abu Musa Island sitting on the Iranian side like a fortified surveillance platform covering the eastern approach. The IRGC's Ghadir-class submarine program, the swarm doctrine, and the cost asymmetry math that makes Iran's strategy coherent even when it cannot win a direct engagement. We showed you the problem. This video shows you how the problem was solved before it was announced. Start with Iran's strategy, because Iran's strategy is intelligent. The Islamic Republic cannot defeat a United States carrier strike group in a conventional naval engagement. That is not editorial opinion. That is what every wargame run against this scenario produces, at every level of command, over the past 3 decades. The firepower asymmetry is simply too large. A Nimitz-class or Ford-class carrier brings 60 to 70 fixed-wing aircraft, multiple surface combatants each mounting 90-plus vertical launch system cells, and an integrated air defense network that reaches 200 nautical miles in every direction. Iran's conventional surface navy, a collection of aging frigates and corvettes, many with Western systems Iran has been unable to service since 1979, cannot survive that engagement. So Iran did not build a conventional navy to fight that fight. Iran built a disruption machine designed to exploit the specific vulnerabilities of that power at a specific geography. The doctrine is swarming. The IRGC Naval Command operates a fleet of Boghammer-designed speedboats, Blade Runner hull fast attack craft, and converted commercial vessels rigged as weapons platforms. These boats operate at 45 to 55 knots. From the time they depart their pens at Bandar Abbas to the moment they reach the Strait's Narrows, the transit covers roughly 26 minutes. 26 minutes. Against a vessel with a radar cross-section comparable to a large pickup truck, moving at highway speed, in a shipping lane averaging 300-plus commercial vessel transits every single day. Look at the cost math, because the math is the doctrine. A single RIM-116 rolling airframe missile, one of the primary close-in engagement weapons mounted on U.S. surface combatants, costs approximately $905,000 per round. The Boghammer, it is designed to intercept costs roughly $35,000 to build and put to sea. That is a 26-to-1 cost ratio. In Iran's favor, before the first impact, before a single sailor is threatened. Now run the attrition equation across a coordinated swarm of 50 to 60 boats converging from 3 separate vectors simultaneously. The Phalanx C IWS on a Burke-class destroyer empties its 1,550-round magazine in approximately 22 seconds of sustained fire against a single engaged target. Against one threat vector, decisive. Against 50 coordinated boats closing from multiple bearings, the magazine runs dry before the engagement resolves. Iran does not need to sink a destroyer. Iran needs to drain the magazine, force the convoy to maneuver, break the transit schedule, and impose insurance and charter rate costs on every commercial vessel operator in the world watching the footage. Global shipping insurance rates for Hormuz transits moved over 400% the last time the IRGC sustained an interdiction campaign. That is Iran's economic weapon, and it does not require sinking a single U.S. warship to deploy it. That is the surface layer of the problem. The underwater layer is the Ghadir-class submarine program. Iran operates between 21 and 29 Ghadir-class boats. The exact operational inventory remains a disputed intelligence estimate, based primarily at Bandar Abbas and the Chabahar naval facility on the Gulf of Oman coast. The Ghadir is a small platform by any standard, 29 meters in length, 114 tons displacement submerged, a diesel-electric propulsion plant rated for modest underwater speed, and an armament of 2 heavyweight 533mm torpedoes. By United States or Russian submarine standards, it is an unsophisticated system. In the Persian Gulf, unsophisticated is adequate. The Gulf's average depth is 50 meters. Maximum depth along portions of the Iranian coastline approaches 90 meters in specific zones. At those depths, the Gulf's seasonal thermocline structure, layers of water at different temperatures that bend and absorb acoustic energy in patterns that shift dramatically with season and weather, creates what submariners call sound shadow zones. Areas where passive sonar range collapses from the tens of nautical miles available in open ocean to under 5 nautical miles in adverse conditions. A Ghadir sitting at 30 meters in a Gulf sound shadow zone, running on battery power with its diesel plant shut down, is genuinely difficult to detect with airborne or surface sonar. Not impossible, but difficult enough that it imposes significant search costs on every anti-submarine warfare asset in the theater. And with 21 to 29 boats in operation, Iran can sustain a persistent submarine presence across the Gulf's critical zones, even with routine maintenance and crew rotation pulling a portion of the fleet off patrol at any given time. That submarine presence changes the risk calculation for every tanker transiting the strait. Even if the probability of a Ghadir intercepting any specific vessel is low, the possibility exists. Insurers price possibility. Shipping operators price possibility. The economic disruption does not require an actual torpedo. It requires the credible threat of one. And then there is the third layer, the one that makes both problems harder to solve from outside. Surveillance itself is visible. Every P-8 Poseidon Maritime Patrol aircraft departing Bahrain on a Gulf patrol flies over Iranian radar coverage from the moment it clears the Bahraini coast. Iran's electronic intelligence stations along the Gulf shoreline have been cataloging P-8 route profiles, altitude patterns, and departure timing since the platform entered theater operations. Within 3 sorties on any given route geometry, the pattern is characterized. Within a month, it is predictable. Satellite imagery from commercial and national technical collection assets provides revisit cycles over Bandar Abbas at intervals Iran has mapped. The optical and radar satellites follow orbital mechanics. Orbital mechanics are not classified. Any competent engineer with access to public tracking data knows when a given satellite is imaging a given point on Earth. Iran's command structures manage activity at Bandar Abbas against those revisit windows. Visible posturing when Iran wants to signal resolve, dispersal and concealment when Iran wants to move quietly. $400 million. That is the approximate cumulative investment Iran has made in its coastal sensor network, the fixed radar installations, the electro-optical surveillance platforms, the signals intelligence collection nodes running 24 hours a day along 2,400 kilometers of Gulf coastline. The purpose is straightforward. Know when you are being watched. Manage what the watcher sees. Time your operational movements to the gaps in collection. For 3 decades, that investment returned value. The collection architecture arrayed against Iran from the outside. P-8 patrols, satellite passes, surface ship passive sensors operating from known positions gave Iran a manageable information environment. Iran knew the schedule. Iran worked the schedule. The military activity Iran wanted the U.S. to see was visible when the U.S. was looking. The military activity Iran wanted to conceal was not visible when the U.S. was looking, because Iran had spent $40 million a year training operators to manage exactly that. The $400 million surveillance network was designed to detect the U.S. surveillance pattern. It did precisely what it was built to do. Here is what that means for the conventional kill chain. Standard intelligence preparation of the battlefield at Hormuz follows a cycle: collection, processing, targeting, execute. The cycle has a minimum duration. Imagery intelligence collected on a 90-minute satellite revisit is already 90 minutes old before it reaches a targeting officer. The targeting officer assembles a package. The package moves through a command chain. Authority is delegated. The target moves. The package is updated. The cycle runs again. In open ocean or long-range land attack scenarios, this cycle runs on timelines measured in hours. Against time-sensitive targets in a dynamic littoral environment, Boghammer speedboats covering 26 minutes from pens to threat range, Ghadir submarines that can move between sound shadow zones on battery power in under an hour, the cycle is structurally too slow. The conventional targeting chain was built to respond. In a 21 nautical mile choke point, response is too late. Iran's planners understood this. Every IRGC Naval Command wargame scenario run over the past decade exploited this timing gap. The pattern is consistent across what has become available in recovered operational doctrine materials. Announce maximum readiness publicly. Trigger the U.S. response surge. Use the U.S. repositioning window, the days when carrier assets are in transit and temporarily out of optimal engagement geometry, to preposition swarm assets deeper in the strait. The announcement is the distraction. The prepositioning behind the announcement is the operation. I spent considerable time going through what is available of the operational timeline for this sequence, and one detail kept coming back. The gap between what the standard ISR architecture was showing, normal activity at Bandar Abbas, no imminent surge indicators, elevated but non-critical posture, and what the submarine had logged across 38 days of passive collection was not marginal. It was comprehensive. The two pictures of Iranian naval readiness did not resemble each other. That gap is the story, not the strike counts. The gap. The Ohio-class SSGN was not designed for this mission. That is engineering history, not criticism. The 4 boats in the converted class, USS Michigan, USS Ohio, USS Florida, USS Georgia, were originally laid down as Trident II D5 ballistic missile submarines in the 1980s. They carried 24 intercontinental ballistic missiles each and operated on nuclear deterrence patrol in the North Atlantic and North Pacific as the foundation of the sea-based leg of the U.S. nuclear triad. Their purpose was to absorb a Soviet first strike and survive it long enough to retaliate. They were built for a world-ending scenario, and they were built extremely well. In 2002, the strategic environment had changed enough that conversion became viable. The 4 oldest boats, too old for the Trident II life extension program but too capable to decommission, were redesignated. The 24 Trident missile tubes were reconfigured. Each tube now carries 7 Tomahawk Block 5 cruise missiles, giving the converted boats 154 VLS cells total. Large dry deck shelter chambers were added aft of the sail for Special Operations Force insertion. The converted SSGN can accommodate up to 66 SEALs and their equipment for extended missions. The boats became the most heavily armed submarines ever commissioned by any navy. But the most important thing the conversion did not change was the propulsion plant. An Ohio-class boat runs on an S-8G pressurized water reactor. Nuclear. It does not surface to recharge batteries. It does not need air for combustion. Its effective range is constrained only by crew provisions and maintenance scheduling. A fully provisioned Ohio-class SSGN can operate submerged and at full readiness for 90 days without surfacing. In the Persian Gulf, that endurance is not a logistical advantage. It is a strategic weapon. Here is the engineering detail that makes this specific deployment matter. Put yourself in the position of the IRGC command at Bandar Abbas. You are running a $400 million surveillance network calibrated to detect American ISR activity. You are logging P-8 patrol routes, satellite coverage windows, surface ship positions, electromagnetic signatures of collection platforms. You are managing your naval force posture to show what you want shown and conceal what you want hidden. Your surveillance architecture was built to detect platforms that must show themselves, aircraft that fly observable routes, ships that move detectable wake patterns, satellites that pass predictable orbital tracks. It was not built to detect an 18,750-ton submarine sitting motionless in a sound shadow zone 40 nautical miles from your harbor for 5 weeks, because there is nothing to detect. The S-8G reactor, at reduced power cruise settings, operates at acoustic output levels that fall below the detection threshold of the filtering algorithms Iran's passive sonar network uses to separate military contacts from commercial shipping noise in a high-traffic environment. The Ohio-class boat was not invisible to Iran's sensors. It was indistinguishable from background. It was not there as far as the sensor network was concerned, and it had not been there for 38 days. What it had been doing during those 38 days is where the intelligence collection story gets genuinely strange. The BQQ-10 sonar suite mounted on an Ohio-class submarine is a broadband passive array. No transmission, no acoustic emission, nothing that can be detected by any active sonar system in the operational area. In open ocean conditions, effective detection range runs to tens of nautical miles. In the Persian Gulf's acoustically complex shallow water environment, compressed range, elevated ambient noise from commercial traffic, variable thermocline geometry, the effective collection range is reduced. What the geometry reduces, the time compensates. Every Ghadir-class submarine departure from Bandar Abbas, logged. The acoustic signature of a diesel-electric submarine starting its propulsion plant is distinctive. The specific combination of propeller blade rate harmonics, auxiliary machinery vibration signatures, and low-frequency motor emission profiles is not identical between individual boats, but it is consistent enough within a boat's operating history to classify and track across multiple sorties. After the third departure on a given route, the pattern begins to emerge. After the 8th, you can forecast the 9th. Every Bog Hamar fast attack craft fueling cycle. Logged. The noise signature of a diesel fuel transfer pumps running at a harbor pier is distinct from ambient background noise, and the IRGC's pre-mission fueling protocol is consistent. 4 to 6 hours before a departure, fuel tanks are topped off because the operational range envelope of the Boghammer makes a full fuel load the difference between completing a mission and being stranded at sea. Log the fueling pump noise, and you log the departure calendar. Every coastal radar installation's duty cycle. Characterized. Active radar systems emit. The emission schedule of Iran's coastal radar network, the power-on intervals, the frequency agility patterns, the maintenance rotation that takes each station temporarily offline, can be built from 38 days of passive electronic collection. Each station's gap in coverage becomes a known window, a window you can time a Tomahawk transit through. By the end of the 38th day, the submarine carried something that 3 decades of surface and airborne collection over Bandar Abbas had never produced: a real-time, internally consistent operational picture of Iranian naval activity, collected from inside the Iranian detection perimeter, at the pace and rhythm of the target force, with 0 detection events across the entire collection period. Run the cost asymmetry equation in full. Iran's $400 million coastal sensor network, designed and built over 30 years specifically to characterize U.S. surveillance patterns and manage Iranian operational security against external collection. Effective against every airborne, surface, and satellite collection platform in the theater. The SSGN patrol variable operating cost for 38 days, approximately $2 million in consumables, crew provisions, maintenance float, and associated support costs against capital already invested in the platform, $2 million against $400 million. The entire Iranian information management investment, 3 decades, hundreds of millions of dollars, thousands of trained operators, was irrelevant to a platform it was never architected to detect. That is not a technology victory. It is a geometry victory. The submarine fit nowhere in the detection model because the detection model was not built for something that does not move and does not transmit. Drop silent in the comments if this changes how you understand what submarines actually do. Here is where the collection operation almost broke down. At day 26 of the patrol, one of the tracked Ghadir contacts, the 7th distinct boat the crew had profiled across the deployment, departed Bandar Abbas on a heading and speed profile that deviated significantly from every previous logged pattern. Instead of following the shallow coastal shelf route along the northern Gulf shoreline that every previous departure had used, Boat 7 moved to mid-channel, reduced speed, and descended into a thermocline density layer at approximately 38 meters. Contact lost. For 6 hours, Boat 7 generated no acoustic signature the passive array could resolve above background noise. The thermal layer was acting as an acoustic mirror, bending the target's signature below and away from the collection geometry. The commanding officer had a binary decision: close the range, reduce standoff, accept some increase in the Ohio's own acoustic detection risk, attempt to maneuver below or around the thermal layer and reacquire, or hold position, maintain complete patrol silence, and wait. Closing the range risked more than detection by Boat 7. Any Ghadir repositioning in an unusual manner might indicate a coordinated movement, potentially with surface assets or coastal sensors acting as the directing element. Moving the Ohio to reacquire could mean moving it towards something that was already looking for it. The boat held. 11 hours after contact loss, Boat 7 snorkeled, raised its snorkel mast to run the diesel engine and recharge batteries. Standard diesel-electric operating procedure, unavoidable, and the acoustic contact was immediately reacquired. The deviation was later reconstructed through post-patrol analysis. Boat 7 had received an encrypted radio transmission mid-transit, altered course to investigate a surface radar contact that turned out to be commercial traffic, found nothing of military significance, and diverted back to Bandar Abbas rather than continuing to patrol area. The intelligence package was intact, but for 6 hours, a submarine holding the most valuable tactical intelligence in the Persian Gulf had been tracking a contact that might have been on an approach vector and could tell no one. That is the nature of this kind of collection operation. You decide alone, with incomplete information, in conditions where the wrong decision ends not just the mission, but the boat, and whatever you decide is what happens. The commanding officer held. The contact returned. The package was complete. By the time the 38th day closed, the target folders were loaded into the Tomahawk mission computers, coordinates assigned, timing calculated against the coastal radar gap schedule built from 38 days of passive electronic collection. Ghadir pen assignments cross-referenced to departure logs to confirm which boats were in harbor on which days. The kill chain was closed. What no external observer and no IRGC commander at Bandar Abbas knew was that the sequence was already executed in all but the final authorization step. The confrontation existed. It had been running for 5 weeks. Iran simply had not been told yet. What happened over the next 11 days was the visible part. Here is the full system equation. The IRGC escalation model is structurally elegant and historically validated. Iran announces maximum fleet readiness. The U.S. repositions carrier assets. A carrier repositioning takes 72 to 96 hours and is trackable on every commercial maritime monitoring service in the world. Surface combatant surge movements are equally visible to Iran's coastal radar network. The logistical signatures of a U.S. military escalation, tanker aircraft repositioning, ammunition ship movements, surge maintenance cycles at Bahrain, are observable and noisy. Iran uses the repositioning window to pre-position swarm assets further into the strait, behind the announcement, while U.S. sensors are focused on the declared threat. The announcement is the distraction. The pre-positioning is the operation. The model worked every time Iran ran the simulation because the simulation's starting condition was always the same. The U.S. begins uninformed and must build its picture in real time in response to what Iran reveals. That starting condition did not exist here. The Tomahawk packages preloaded in the vertical launch cells had target coordinates entered 38 days earlier. Ghadir submarine pens at Bandar Abbas. Each pen's position on the harbor layout confirmed through acoustic departure log cross-referencing. Fast attack craft staging berths, mapped with fueling cycle timing attached. So the targeting package knew not just where the boats were, but which ones were at pre-mission preparation status at any given hour. Coastal radar installations. Strike coordinates paired with the coverage gap schedule. So each Tomahawk transit route was planned through a window when the radar it would pass under was in its maintenance rotation and offline. When Iran announced maximum readiness and triggered the standard visible U.S. response surge, the carrier repositioning, the surface combatant concentration near the strait, it also triggered something it had no awareness of: the execute authorization. The Tomahawk Block 5 flies at Mach 0.75. From a patrol box in the Central Gulf to Bandar Abbas. Flight time under 60 minutes. The coastal radar gap windows that the patrol had spent 38 days mapping were 15 to 25 minutes in duration, more than sufficient for a subsonic missile flying a pre-calculated terrain-following route at low altitude. The strikes went through the windows. The Ghadir boats in their pens were struck before the first IRGC fast boat swarm completed its departure sequence. The coastal radar network went to partial coverage in the opening 90 minutes. The command center at Bandar Abbas was assessing its sensor picture against a reality that had already been decided, but the sensor picture it was using had been degraded by a strike plan built from intelligence the sensors had never detected being collected. Here is what this tells us about how modern naval competition actually works, and it is not a comfortable observation. The United States military spent 30 years and enormous resources building a surveillance architecture over the Persian Gulf. That architecture was visible. It was predictable. Iran spent 30 years and $400 million building a system specifically designed to manage and exploit its predictability. Both investments worked as designed. They produced an equilibrium in which the U.S. could see what Iran chose to show, and Iran could time its operations against the gaps. The Ohio-class SSGN did not improve the U.S. surveillance architecture. It went underneath it entirely, and in doing so, it negated not the Iranian sensors, but the entire operational security doctrine Iran had built around what U.S. sensors could and could not detect. Iran built an entire escalation strategy around controlling the information environment. The submarine operated outside that information environment entirely. Here is the take that will get some pushback, and we are comfortable with it. The decision to not use the SSGN collection as a deterrent signal, to not surface, transmit, or leak the deployment as a coercive message to Tehran during those 38 days, was the single most consequential strategic decision made in this sequence. Not the Tomahawk strike packages, not the carrier repositioning optics, the silence. Iran's escalation model had been calibrated against 30 years of U.S. deterrent signaling. One more signal would have been absorbed, adapted to, and gamed. The silence was not a failure to communicate. The silence was the communication. And it said something Iran's model had no response to. We were already there. Is that the right call strategically? Or should the deployment have been disclosed to deter escalation before it started? Drop your answer in the comments. There is no clean consensus on this, and we want to hear where you land. Subscribe to Navy Powerline. Because what we showed you in the last 3 videos, the problem, the geometry, the adversary's logic, this video just showed you the solution they built under all of it. Here is one detail that kept coming back through this analysis, and it is not a number or a coordinate. The submarine crew was underwater for 38 days with a complete, continuously updated intelligence picture of an adversary's naval force, and they transmitted none of it in real time. Everything logged, everything stored, nothing sent. The radio silence that made the collection operationally viable also meant that for the duration of the patrol, every piece of intelligence on Iranian naval readiness that the crew was accumulating existed exclusively in the onboard data systems of one submarine that the rest of the fleet did not know the specific location of. The commanding officer held the decision authority for whether to surface and transmit, accepting the detection risk, potentially exposing the patrol position, certainly ending the collection operation, or to continue holding. Across 38 days, at every decision point where that calculus was run, the answer was the same. Hold. That authority, and the weight of it, does not appear in press releases. It does not appear in operational summaries. It appears in the career records of one officer and in the quiet institutional knowledge of the submarine force. And the call was right. Here is what remains unresolved. Iran's institutional response to a successful collection and preemption operation is not withdrawal from the doctrine that was penetrated. The IRGC's history runs through Operation Praying Mantis in 1988, when the United States destroyed half of Iran's operational surface fleet in a single day's engagement. Iran did not abandon its naval program after that. It rebuilt the program, specifically redesigned from the ground up to exploit the gaps in U.S. conventional naval response that Praying Mantis revealed. The swarm doctrine is the product of that adaptation. After this, the same process begins again. Ghadir patrol patterns will change. Departure timing randomized, routing varied, predictability reduced at some cost to operational efficiency, but with a clear gain in detection resistance. The coastal radar schedule will be modified to introduce irregular duty cycles that make long-duration passive characterization harder. Speedboat staging procedures will be distributed to secondary and tertiary facilities away from Bandar Abbas, spreading the target set across geography the patrol box did not cover. None of this closes the fundamental advantage the SSGN doctrine demonstrated. A nuclear-powered boat can reposition to a new patrol box. The 38-day collection method is not anchored to Bandar Abbas. It is a replicable doctrine applicable against any coastal military force that relies on a surface airborne satellite detection architecture and operates on any degree of pattern predictability. But Iran will try to close the gap. The research program to develop a reliable detection capability against low acoustic output nuclear submarines operating in the Gulf's complex acoustic environment will accelerate after this engagement. Passive acoustic arrays on the Gulf floor networked with coastal collection nodes. Unmanned underwater vehicles on persistent patrol routes. Commercial vessel acoustic picket networks. Iran has explored all of these concepts in various programs. None have produced reliable detection against a platform operating at Ohio-class acoustic output levels in Gulf conditions. The acceleration of that research is the predictable response, and the response to that research is probably already in a program somewhere in the U.S. submarine community. The equation we showed you today is not a Hormuz equation. It is a choke point equation. Taiwan Strait, the Luzon Strait, the Baltic approaches. Constrained geography with an adversary that has built its strategy around managing what the external surveillance architecture can detect, and a platform doctrine that can operate inside that architecture without fitting into its detection model. Different geography, same equation. Will Iran's next-generation detection program close the gap on Ohio-class SSGN operations within 5 years? Comment yes or no. Subscribe to Navy Powerline. We do not celebrate weapons. We calculate whether they work. What we showed you today is the calculation running underneath every naval standoff that the headlines reduce to missile counts and carrier positions. The submarine that does not move is the one that closes the equation before the other side knows the problem has been stated.